Da.
So, my name is Marcin Kulik, and I'll talk today about how asciinema project uses Rust. And before we go to the meat of the presentation, I'll just address the name of the project, since it's been like a problematic for like years, the name asciinema. Some people were just like mispronouncing a lot and using
Marcin, one suggestion, because you are silent speaker, so maybe use the microphone, because that I cannot give you the guarantee that this voice will be recorded correctly.
Sure. Test. Słychać coś? Halo.
Jest włączone?
Hello. Okay. Yeah. So I was saying that the name is, the asciinema name is problematic, but I like it. So I pronounce it asciinema. That's because when I invented the name, it was a combination of ASCII and cinema, and basically, I don't know what's the word. The combination. So, just a bit about me. I've been a computer geek for a long time, and I also am an open source contributor for like 15 years or more. And currently I work as an independent software consultant, specializing in Rust and Elixir. And I created the asciinema project. So what's asciinema and why are we talking about this today? So this is a tool for recording, replaying, and sharing terminal sessions. And it's fully open source. Code is on GitHub. There's like a full documentation site for like how you can use it, how you can self-host it, and everything's there. If you want to follow the project updates somewhere on social media, then there's a Mastodon account on the Mastodon instance. So the components of asciinema are the CLI, the player, and the server. These are the three main ones. And we'll go over them and how they use Rust. Because not all of those components are written in Rust like fully, completely, but they do use Rust. And there's this fourth element which kind of like connects them all, because this is the one that's used by all three above. The AVT library, Rust library I built, which is a small purpose-built terminal emulator. So how asciinema works, how it records the terminal. So it uses a PTY, which is a mechanism provided by Unix-like systems, and this is available since like at least 90s, I think, or something like that. It's basically a way of forking a process and making it feel like it's running inside an actual real terminal, but it's actually like virtualized terminal. So you can do some nice things like basically intercept all the input and output that comes in and out of a shell, for example. So this is what asciinema recorded does. Like it uses PTY, and there's more information about the details of how this is implemented. But one thing to note here is that the PTY is used by tools like GNU Screen, like Tmux, SSH even. And basically that's the base of the whole recording process. So the CLI also, I'll refer to it also as a recorder. Initially it was a simple Python script, like 12 years ago, but then it grew, and then suddenly I rewritten it in Rust like almost 2 years ago. And it uses this AVT, the virtual terminal library, for some functionality. And so this is how, like, example commands that it supports. You can stream, so you run asciinema stream, and then your whole terminal session gets live streamed. You can record to a file, you can replay the session from that file, you can upload the file to the asciinema server, which is like a platform for hosting recordings, and then you can convert the session into like a plain text log file also, for example. Then there's the player, which is a web player that runs in the browser. It also uses Rust, even though it's in the browser. So, as you may think, it uses WebAssembly. So the player looks like this. It's cut off a bit, but yeah, it's just like a regular video player, but it's not a video player at all. It's a custom player built from scratch, which replaces all the sessions, and all the text that you see there is actually almost. Yeah, so you can see there's like a control bar below that you can like move back and forth, play pause, resume, etc. And nice thing about this player is that actually you can select and copy paste text from it, because it's not pixels like from a video, but just text. And also another nice thing is that it auto scales. Like if you regardless of your screen size or web browser window size, it also scales the font size, so it's always sharpened. So you can always see all the details there. Yeah. So as I mentioned, the server is a hosting platform for the recordings, and also acts as a kind of a relay or proxy for live streams, and it also uses this Rust AVT library. So the whole project started 14 years ago. I think that this is a screenshot from last year, so 15 years ago. And then it was originally a Ruby on Rails application with some really hacky JS player thing, and 7-8 years ago I written this server side in Elixir using Phoenix framework. That was kind of like, I was planning some more interactive features, like live streaming and stuff like that. So Elixir being built on the airline VM is super awesome for those more interactive use cases, way better than Ruby. So it was worth it, really. And then this is an example of a page, like a recording page, where at the top you have the player embedded there, and below there's some metadata about the recording. You can download the recording, share it, and stuff like that. And here's like some export page where you can browse through publicly published recordings. It displays some like the small preview, the thumbnail of every recording session, and this is also generation of those families is performed by Rust. So this AVT thing that's been like, you know, those components, that's kind of like really my first real Rust project that I started 7 years ago. And the problem I was trying to solve was the slowness of the web player, which was basically the web player is allowing the captured sessions from the file, and it's reinterpreting the whole output stream to build like a visual representation of a terminal. So it's kind of like it needs to do a terminal emulation, at least some part of it. So it was in JS. JS is not really like super fast language, so that for like a more like heavy animated sessions. Thank you. That was very slow, and it was not nice to look at. So I thought, okay, maybe this could be like a nice project to get myself into Rust, and then so I decided to build like a terminal emulator as my first Rust project, actually. And then the idea was that I will just compile that to WebAssembly and then embed that as a core inside of the whole like bigger JS player, right? And it's not really like, not really a full emulator. It's just dealing with parsing all the output that was captured before during the recording, and building like maintaining a virtual terminal screen buffer, like a grid of characters, and also some additional state that terminals pretty much keep, like cursor position and colors and many other things there. It doesn't handle like all the, for example, keyboard inputs, or so you can't really build a regular terminal emulator with it. But that's on purpose. There are other libraries there for that, and I needed something small that will be lightweight and can be embedded in the JS player. So it's also published to the crates as a AVT crate, so can be used potentially if someone wants to do that. I'm not sure if it's like super useful outside of asciinema scope for anyone, but it's there. And yeah, so how do I use this Rust thing in the JS player? So there's this nice wasm-pack project which allows compiling a Rust codebase into WebAssembly, and it also generates JavaScript bindings to this. So basically, as an input, you give it a typical Rust project source tree with a carved toml and all the standard stuff. And as an output, you get a JavaScript module that you can import in your JavaScript project. So on the Rust side, it looks like this. You just use some prelude stuff there, and because you can't, so this in line 5, the AVT VT. This is the actual virtual terminal from the AVT library, but you cannot expose any arbitrary type to the JavaScript using this wasm-pack. You need to wrap it in another struct, because you need to annotate this with this wasm-packed macro, which makes the whole generates the bindings basically. Then or this is an example of a function that creates an instance of this VT, the wrapped VT. So there really isn't like anything special here other than the wrapping part. The rewrap VT in this local VT struct. And then implementing some methods on this wrapper. Also needs line 17, this wasn't bind gem. And then a few things to note here are like the feed method. This is the method which feeds some data into this terminal emulator. And by doing that, it updates its internal state and updates the virtual screen grid, screen buffer. This feed str method, the changes variable here, it's a hash map if I remember correctly. So you cannot really return like more complex types directly to the JS side. So you need to use some special utilities, like there's a serde wasn't bindgen library which serializes different values so they can be like, unserialized properly into JavaScript objects. So that's what we were doing here. And then the JS value return type here is exactly like the output of the serde wasn't bindgen to value. That's what it does there. The get size method is simpler because simple types and also including vectors and strings can be directly returned, and then they just get handled just fine. So there's nothing really special here. So it can be like returning the size of the terminal, so pretty much two numbers. It can be done in multiple ways. I decided to just use a vector here, and on the JavaScript side it will be a two-element array. So yeah, this is how we interface with this code from the JavaScript side. You can actually import this cargo tone directly if you have if you use. There are several JavaScript bundler plugins that can do that. So you just point it to cargo toml, and then it will build. When you're building your JS bundle, it will invoke the Rust compiler, then prepare all the WebAssembly chunks and everything there, and the bindings. And you need to await for that because this is being loaded asynchronously. But after that, you can just call those methods there. So wasn't create is the one that we saw here, and then you can just call like feed get size, and it just works pretty simple, at least on this side. So yeah, this is the example output of like building the JS player, and there's a couple of things here, like the unminified full player bundle is almost 300 kilobytes, so not small. So that's the reason for that is also that the WebAssembly bytecode is embedded in it. That's because I wanted this to be like, it makes distributing the library way easier. But because embedding like raw binaries, you can't do that inside JS files, then the WebAssembly is actually base 64 encoded, so it's slightly like 33% larger than it could have been. But the player is also built like in like split mode, where you have like a UI that you just initialize on the page, and there's a worker part which embeds this RustCracow, and it runs in the browser's web worker thread. So the worker here 200K is most or 3/4 of it is probably the WebAssembly there. When Minify is smaller and when this thing is sent as a compressed file or compressed on the fly by a web server, it's like 60 kilobytes. So in the end, not bad. Yeah, so the server part, as I mentioned, it handles like preparing those thumbnails, generating also plain text view of those sessions. So on every recording page you have a download drop down where you can download the original recording file, or you can download a text representation of it, like just plain text with no control sequences and anything there. And this is also using Rust and AVT for that. And also Rust is using the server for streaming. So again, AVT is used there for like maintaining the live stream state. And I mentioned that the server is written in Elixir. So this is another thing that I needed. The Rustler project, which allows you to use Rust code from Elixir or Erlang. And it mentions the nifs. So nifs are natively implemented functions in Erlang and Elixir. So basically, it's like your Python's native C extensions or stuff like that, pretty much. So you can invoke some low-level code from Elixir there. And yeah, so here's like how to prepare some Rust code to be exposed to Elixir, for example. Yeah, I guess so. There's this development thing is not really interesting much. But again, here we need to wrap the actual AVT virtual terminal struct in our own struct and also into a log. That's what the Rustler expects. So it's like safe and it doesn't crash the Erlang VM at any point due to some concurrency issues, etc. Yeah, it requires, the Rustler requires like implementing this marker trait for our own struct in order to be able to expose it, and then this load callback is used for registering this struct as something that's available from Elixir. And here is like a similar thing. We use a Rustler nif macro annotation for a function. So this is very similar to the create function that was built for the JS interrupt. Yeah, this one has slightly more logic. It just checks if the size is right. If it's right, and it builds the line 25. We are building the actual VT, and then we wrap it like, I guess, 3 times in a log, in our VT struct, and in a resource arc. This is kind of like a bit of boilerplate, but it typically looks like this. It's something you just do once, and that's pretty much it. And this is a function that you can then call on the resource. So Elixir, as a functional language, doesn't have like methods and objects, so everything is a function. So we are, instead of implementing a method on this VT wrapper struct, we are just implementing a regular function that accepts this resource as a first argument and gets some additional arguments for like its operation within it. And here, just we need to get this actual inner virtual terminal So there's a bit of like resource. So we get the internal VT, which is like a read-write log. We need to acquire the log. I use unsafe unwrap here because the error handling wouldn't fit on the slide here, but you get the point. And here there's like a simple match, like checking if the string that we are passing from Elixir is a proper UTF-8. So in case it is, this avoids all like any memory copying, so it's very fast. And because this STR from UTF-8 turns byte slice into a string slice, the string reference. And if it's not really valid, which shouldn't happen, but I have this case here anyway, it converts it to a lossy, the full string, and then feeds that. So you can actually, with JavaScript and Rust, there's, because of how WebAssembly deals with types, there's no real way of like passing values between JS and Rust without copying. There's always some form of copying or serialization. Here, because Elixir code invokes those like a code in the C, using the C ABI, standard C ABI. So it can actually use some optimizations and just refer to pointers in memory. So a string in Elixir is directly referenced here without any copies, which is nice. And here's another method that's used. So this is one we will see in a moment, the dump. So the dump method on AVT virtual terminal returns like a full terminal state as a string that can be fed into a brand new VT instance to turn it into the same exact state. So state by state I mean both a visual thing, so all the characters and lines and everything, but also some internal variables of the state machine. And this is how it looks from the Elixir side. You need to create a module and create some placeholder functions for the functions that will be loaded from this native library. I'm not going to go into details here too much. But yeah, this is how you use it from Elixir. Create a VT, feed it, and then you can dump. Also simple. And yeah, now the Rust and CLI. So since almost 2 years ago, the CLI, the recorder, is written in Rust, and there are many reasons for me to rewrite it from Python. One is that I totally don't want to use Python these days anymore, since I learned Rust. I wanted to use this AVT for the purposes of live streaming, which helps with that. And I could do the same as I did with the others. So have the Python CLI and use Rust as a native extension. There's Pyo3 project which lets you compile Rust to Python's native extension. But I just had other reasons also for moving to Rust with the CLI, so it happened. So the asciinema CLI has two ways of how you can stream a terminal, local and remote. Local basically launches like a built-in web server on the local port, and you can just point your browser directly at it. If you can expose that port on the internet if you're adventurous, or you can send a URL to it over a colleague that's on the same local network, maybe. But for the most people, there's some form of like public server needed to be part of relaying the stream. So the remote mode is basically the CLI forwards the whole stream to the server, and the clients, the viewers, are opening the stream on the website, and the JS connects to the server from the other side to receive the stream. Yeah, and I'll focus only on the remote part because this is more interesting, and this is where more Rust is used. When you start streaming and then you do some stuff on terminal, some programs print some output, and then everything that you see on the screen in your actual terminal gets captured as a raw stream of bytes, and this gets sent to the server. The CLI opens the WebSocket connection to the server, and then forwards every single byte that it sees to there. So like in a raw, unaltered form, and then the player connects to the server and receives also over WebSocket those raw bytes. But the player also has this internal virtual emulator, so it feeds the in-browser emulator with those raw bytes, and it gets the same terminal view as you have in your own actual terminal. So this is good, but then what about the case where someone connects, opens your live stream later? So you have something on your screen, and then they just connect. We can't just we can't just start sending them new bytes that are printed, because also we need to send them some initial the state of the terminal. So the subsequent messages that are received will be built on top of the proper context, proper state, right? So this is one problem to solve. And another thing is like when there's the CLI which is connected to the server, which is forwarding all the stuff, all the whole stream to it. If the CLI gets disconnected, you're a streamer, you're sharing your terminal, and then your ISP decides that it needs to reset some routers or some switches somewhere, and then you get disconnected from the server. So the viewers are still connected to the server, but you as a streamer, as a producer of the stream, you are not anymore. So the CLI keeps like a reconnection loop in the background and tries to reconnect. But then meanwhile, like while it's trying to reconnect but it can't, you are doing stuff in the terminal, so the contents change. So we also need to like get the server up to speed with what changed since we lost the connection, right? So yeah, so AVD and this dump method kind of solves nicely. So this is for the case where the player connects initially or reconnects because the player was disconnected as well. The top code piece is the server side in the Elixir, and what basically happens is that every stream has its own like process, lightweight process in the LLVM, and every process has some state, and in this state there is a stream, and the stream has this instance of a virtual terminal. So for every person who starts streaming, there's a new process being spawned, and then each of those processes has its own independent virtual terminal. So we can access it, call dump, and get this string, which is like used for seeding the player, seeding the virtual terminal in the player. It subscribes for the stream ID, so everything new that happens will be also it will know about it and will be able to forward it. But for this initial handshake, connection handshake, it just sends the current terminal size, so columns, rows, and the seed. And on the JS side, we receive this as a message, the initial message upon the socket connection, and we use this WASM, so this WASM module to create an instance. So this is pretty much what we saw earlier, the JS slides. So we are seeding this VT with this, and then at this moment the virtual terminal is up to speed with what's on the server, and then later it will just be fed more data as it comes. And similarly, on this other end, between CLI and the server, on the producer side, when it reconnects, so the CLI also, when you're streaming, the CLI has its own virtual terminal in memory. So in addition to you running the stuff in your own terminal, and the CLI also sending all those outputs through the WebSocket to the server, it also maintains its own virtual terminal, because it really needs to know, at the point of reconnection, it needs to know the full state of what's on your own terminal. So it builds it maintains its own view of it, right, using the AVT library. So similar, dumps, sends it, and the Elixir server similarly decomposes the message, and then does a very similar thing there. Yeah, I think that's it. So I just want to say that it's awesome that there are all those libraries like RustCracow and WASM-Pack and then Pyro 3, that you pretty much can integrate Rust in any language that you imagine, really. These days, maybe it was harder 5-10 years ago, for sure, but today it's pretty easy. So this is also nice way of if you can't really convince your company or colleagues to rewrite everything in Rust, if you have some performance problem or mostly a really good argument, then you can creep in a bit of Rust into your project by using all those integration libraries, and then maybe from there people will like it more and more and more, and then more things will be rewritten in Rust. Thank you. Any questions?
I have one question. So congratulations for a very, very long project, very age, I would say.
Thank you.
But according to your experience, because you said you wrote this project first in Ruby and Rails, or Ruby, sorry. Later it was Python, as I understood.
Yeah, so different components were written in different. So the server, the site with the API for uploads, etc., was originally Ruby on Rails, and at the same time, the CLI for recording was in Python.
Yeah, and also Elixir was involved, as I.
Yeah. So later, the Ruby on Rails implementation was rewritten in Elixir, and the Python implementation of the CLI was written in Rust.
Okay, so
in parallel, in different. Yeah, the timeline was different, but
Yeah, so that's the point of my question. What's your general feeling about Rust in comparison all of those languages? I mean, is in terms of if it's better to develop, if it's better than why, if it's easier, whatever. If you can make some short summary about this journey of leading to Rust in the end of this project,
Sure.
which is
Yeah. So I think for the CLI projects in general, not my CLI, but any CLI project, Rust is pretty good fit. Like it's you know it's fast, so you know the CLI starts and performs like what it needs to do immediately. There's no like with Python CLI there was this Python you know this bytecode interpretation and all this stuff, and so there's some overhead. So it's not that you know it's not that satisfying. Like you run, you know, there's so many new tools that are like rewritten versions of some older Unix tools, and those Rust versions like are super satisfying because they not only are they modern, like fulfilling our current needs, they're also super fast and they just like have and they often use this club library, which is Rust's command line command line argument parser, I think it's called. It's amazing. I use it in asciinema, and it's amazing. You can just declare all your commands, subcommands, options, flags, what have you, in a nice declarative way, and it handles all of the parsing for you, generates very nice help messages, etc. So this, like, I know that many languages have those libraries. Python has, I think, called Kulik. There's probably a couple of ago, and Ruby. But I just find I use some of them in other languages, and I find Cloud just like to be amazing. So this alone could be, you know, a small argument for using Rust because it handles so many things for you. I wouldn't use Rust for like building like a typical API or like a website. I know people do. I know there are frameworks for that. That's not what I would do. I feel like there are other languages and frameworks that you can be more productive if you're like operating on this higher level where those typical like business logic level APIs, crowd type stuff operates. So I know people successfully use Rust for this type of stuff. I'm of opinion that maybe Rust is not the best idea there. Yeah, I'm not sure if that answers your question.
Answers. Thank you.
So I'm not like put Rust everywhere, even though my presentation was like putting Rust everywhere almost, like JS and Elixir everywhere. But I only put it where it makes sense and helps me, you know, achieve some things, but not like I'm not planning to write the asciinema server in Rust. Yeah.
It's a couple of questions. What was your main motivation for creating this project? Because you started a long time ago, and I'm curious if you had such niche, or you thought that this is a fun project, and like, basically what is the reason for starting it and continuing it for so long time? Yeah.
Well, there was just like I discovered this old Unix script command that was kind of like inspiration for a project. So there is on Linux systems, maybe some of them even have this pre-installed. There's a command called script, and there's a corresponding command script replay, and it can basically record like a terminal session into a file, and then you can use script replay to replay it in the same terminal. So I was just playing with it, and I thought that's super cool. I was like replaying the session, and I was like, oh, it's kind of spooky because it's not me typing, but it's kind of like I was typing when I was watching it inside the terminal. And I was like, yeah, cool. I could record some tutorials for people, for example. I was very into Vim back then, so I could record some Vim tutorials or other stuff. But I thought, how am I going to show those to them, right? And am I going to send those recording files to them over email and ask them to use script replay in their own terminal? That felt like not the way to go, and I thought it would be awesome if there was a way for me to just, host it somewhere and send them a link so they can watch it in the browser. And basically, that was the moment when I thought, okay, maybe I'll try. So, and it was always like a side project for me. So even though it's like almost like 13, 14 years now, I still just enjoy working on that because this is, it's been so much fun, and I could. It also allowed me to learn new languages. Also, like there was nobody telling me you can't do that. You can't write this in Rust. You can't implement an emulator in Rust because we don't have time for that. We don't have budget for that. This was a side project, so it was like a nice playground for me. So that's why I still am doing this, because it's fun, and also there's a quite nice community of people who actually use it, and they like. I'm often getting emails from people like university teachers who are recording their like presentations or like some material for their students, and then they embed those recordings on some HTML page, and then they send this to their students as a material, for example. So I think what keeps me going is also like the fact that I see that it's valuable for other people. So if it was just like me having fun with it, I'm not sure if I would be doing that for like 14 years.
Two questions to that. The first one is, if you look back at all the work you did, and I guess there were a lot of lessons learned, maybe I'm always, it's very useful to know your lessons that you learn in the process and then share that with other people. Like learning through others is very important. Something you want to share?
Yes, so there's one thing I didn't mention here. The player initially was just like a very hacky JS player, and with all the emulation also written JavaScript and all the like. Anyway, it was rubbish, and then it didn't use like a proper approach for parsing the byte stream, because everything the terminal outputs, not terminal, applications running on terminal output, is like not only like text but some control sequences, some special bytes that mean something, and they change the internal state of a terminal's state machine. So this is pretty much like a parsing problem. You need to have a proper parser that gets those bytes as input, and then uses state machine pretty much for like doing this properly. So initially I did this very badly. I didn't use any proper state machine. I used regexes to just imagine some parts of the string that I knew that they were doing some special things like move cursor back and forth or change colors. but there was like a dead end. So I found like a nice diagram of a really good state machine for building terminal emulators. A guy called Paul Williams created this, and I think I believe that many modern terminal emulators like Electric Ghosty, and probably iTerm as well, KT. There are so many. I can count them, but I believe they all are based on this diagram of Paul Williams, who just nicely pulled it all together. And then when you follow this, you will have like a pretty compliant, like, robust parser for this stuff. So I thought, okay, I'll use that, but I don't want to implement this stuff in JS again. And back then I was doing some Clojure work, and Clojure is a Lisp-like language that also compiles. You can compile it to JavaScript. So you write the Clojure code and compile it using Clojure script compiler. So I thought, okay, I will write the player in Clojure. That was like another thing that I didn't mention before. It was not really important from the Rust point of view, but I rewrote this whole player in Clojure, including the terminal emulation part, also in Clojure. But because Clojure is a functional language with immutable data structures, no mutation whatsoever, so everything you change, like individual, like you have like a data structure that represents like grid, two-dimensional characters. If you want to change something in the second row, one thing, you need to replace the whole row with a new row. So like a vector of vectors in Clojure. So you can't mutate it in place. You need to create a new vector with all the existing cells, plus the one change, plus the following ones. And because this one changed, you need to replace the outer vector as well, because you can't also mutate this. And that means that there's so much allocation of memory allocation all the time happening, and also because of the loads of garbage collection, it was totally inefficient. It was like so slow that for like standard like things like I'm typing something in terminal, it was good enough. But if you started, like playing some animation in terminal, it was totally like if you check the browsers like resource manager, like task manager, it was using like 1 gig of memory and like 100% of CPU, because it was constantly like this whole like memory pressure of like allocating the allocate. So the lesson learned was I learned that Clojure script and Clojure in general is not very good idea for like high performance stuff. And then I thought, okay, maybe I'll go back to JS, but then we'll embed Rust using WebAssembly. So that's what I learned. And this works very well. This works very well. And then I don't know. Maybe there were more lessons I learned. I don't remember. One lesson is that be also like not be too smart with naming your project, because people will have problem pronouncing it. But that's another story.
Yeah, one for me as well. First of all, congrats on having such a successful and useful project. I started as a pet project and it's developed like 15 years. And I've seen like on a meetup that there would be like a presentation of asciinema, asciinema by the creator of asciinema. I was kind of surprised because it's something that I'm familiar with. And yeah, as you said, sometimes you just have this really nice library, and at the very README markdown, you basically just have like a screen recorded in the form of a movie. And so yeah, that's weird. while you have tools such as this one. So my question would be, from the perspective of having such a huge project at this point, what is like the most, let's say, the single thing that you see that could be like a change or improve, maybe remove from the Rust as a language, or maybe like in a broader sense from like a maybe Rust ecosystem as a whole, that would make the whole thing even better, let's say.
Remove, change.
Or improve, let's say, like maybe like a, I don't know, maybe that's some kind of syntax that is annoying, maybe some feature that lacks some improvements that people are waiting for years, and you as well. I don't know.
I don't know. Like there was a couple of small things that in the past were annoying, but with every new Rust compiler version being released, probably most of those were like fixed or improved, so they don't annoy me anymore. So I think like the Rust development team is doing a good job of like making sure there's like not too many paper cuts, and so I don't have anything really. Like there were some moments where I was fighting the borrow checker, and I thought, well, I wish Rust had some different way of dealing with this stuff, and maybe like in another universe there's a Rust with garbage collection, because sometimes you don't really need the bare metal performance, but other than performance, the language itself is great. Like the enums, the option types, results, all this stuff like makes you write like a more safe and make safe code, and then be more confident that you're shipping something stable. This is one of the nicest things for me when using Rust, is that refactoring is awesome, because like if you use Rust Analyzer, it helps so much. Like you can like refactor without really like being worried about that you missed something. Either compiler will find problems, or checker will find new problems, Clippy will find problems, and then it compiles, and then you know that you have covered all the enum variants. You know that you have covered all the like options, being none, everything. Unless you do like unwrap everywhere like an animal. If you don't do that, then you're just safe. So this is awesome. With other languages, especially like non-statically typed, I always have this anxiety like releasing stuff because I know there will be something there. I tried actually. I got actually a PR when the CLI was still using Python, and I got a huge PR from someone who added types to like this type decorations for to type Python code, which kinda like gave a little bit of safety here and there, but made the whole code like much more ugly. It's not that Rust isn't verbose, it is, but the typing stuff for Python was like added as an afterthought, like later, and it doesn't feel like well integrated, and I don't know, I don't like it. So
Yeah, I think I know what you mean, because there's this, I can't remember the name, but there is this most popular Python library for types. I've used it once to just see how these days Python is doing when it comes to like semi-static typing, and it's quite massive, but it still feels like a toy project when it comes to like type system. It's like MyPy,
Yeah,
it's
exactly.
like a baby toy really for like a true static programmer.
yeah.
I have a question.
Okay.
Can you share maybe what audience or what are the main two use cases for your product? Like, because I was interested in commercials, so what would be the use cases and audience?
So there's many different use cases. So as I mentioned, there are some university teachers who record some tutorials for people. There's lots of open source projects on GitHub that actually have this like in the README, as you mentioned. Instead of having video, they have like this embedded like a clickable image of a session recorder. So basically a demo of mostly CLI projects. This is so tutorials, demos. I think those are the most biggest two. Especially specifically for the recording part when you record the file. For live streaming, I suppose it's I don't know. It could be it could replace, like if you're with colleagues, you're doing something in terminal, and until now you've been using Zoom to do that. Then you can maybe use this one. The only limitation is here that there is no sound, so you would still need to use Zoom or something. So yeah, the streaming part is really quite new, so I haven't heard like too much feedback from people. But yeah, mostly demos and tutorials, I think. Yeah, if you go to the asciinema.org website and you go to the Explore page, then you can just see like what people record and what people like. Sometimes they just like build some cool animation, and because they feel like, yeah, this is awesome, and they just share it. Sometimes they have some like tutorial for like Vim or Git or something. I think we are out of time. One last question.
I was just about to say that if someone is, for example, having this setup where, for example, someone uses NeoVim, let's say, and is tool for CLI, let's say, presentations, it seems that you can like avoid having this screen recording for sharing, and you can just use like this streaming feature, or I guess like the upcoming or existing streaming feature.
It's already there.
And just use that plus voice with some other application, and you just can have that, right?
Yeah, exactly.
Without like a Zoom or Skype is dead already, but like a Zoom or something else, right?
Yeah, exactly.
With a 4K resolution for everyone.
Yes. Yeah. All right. We can chat about anything like later. I don't want to take more time here. Thank you.